All right, let's take a look and see where you're at, how you're doing on this stuff. So, like I said, last lesson here of Chapter 8. And so we spent the first part graphing. Okay, we spent a week on graphing and all the different stuff, which is what the warm-up is. Then last week we spent simplifying, when you add, subtract, multiply, and divide. Now this week we're going to go into solving. How do you solve rational equations? That's the new lesson for today. And like I said, the final lesson here of Chapter 8. So as we go through and we take a look, let's start with the warm-up, as always here. So same as usual, horizontal asymptote. We just work our way through. Because in this case we've got x squareds in both numerator and denominator, that means we've got a tie. So we take a look at the coefficients. In this case it's 1 over 1. So we have a horizontal asymptote at y equals 1. We can put that in the graph. Then from there, before we worry about the holes or the vertical asymptotes or any of that kind of stuff, now we need to take a look at the factors and see what exactly can x not equal. What in the denominator when we're looking at 0. So let's go ahead and let's factor this. We end up with x minus 2 and x minus 1 over, here we end up with x minus, what, 4? No, plus 4, excuse me. X plus 4 and x minus 1. And so right now, when you take a look at the factors, right now you can identify all those problem points, okay? Because right here, if x were to equal negative 4, we would have 0 in the denominator. And here, if x equals 1, you would have 0 in the denominator, which means we can't have either of those. So I'll put those off to the side. X cannot equal negative 4 or positive 1. Those are the two problem areas, the two problem points, okay? And so now we identify, what are those? Are they vertical asymptotes, holes, one of each, that kind of stuff. And so because the x minus 1s cancel out, that means we do have a hole in the graph. And because it was the x minus 1, that's what the 1 is. The 1 is the x coordinate of the hole in the graph. Which means we're left with x minus 2 over x plus 4. There's your simplified version. And so to find the corresponding y coordinate that goes with that, you take the 1 and just plug it in. Okay? Substitute it in. In the numerator, 1 minus 2 gives me negative 1. In the denominator, 1 plus 4 is 5. So we end up with a negative 1/5 as the y coordinate that goes with it. Okay? So whatever cancels gives you the x coordinate, and then you plug that into the simplified version for the y coordinate. So at 1, negative 1/5, we're somewhere in that vicinity. We have a hole in the graph. Okay? Then we take a look at the vertical asymptotes. And so when you look at your simplified version, x still cannot equal negative 4. Therefore, that's where you have a vertical asymptote. At x equal to negative 4. So there's that part of it. And now the last two things, just to add a few other points in here, as always, the x-intercept and the y-intercept. X-intercept is when y equals 0. Remember, a fraction will equal 0 wherever the numerator equals 0. So in this case, it's when x equals 2. And so we have an x-intercept of 2, 0. So we can put that on the graph. And then a y-intercept, remember, as always, is when x equals 0. So we take 0 and we plug it in and get an answer. And when I plug it into my simplified version here, I get negative 2 over 4. Reduce that, we get negative 1/2. So 0, negative 1/2. Somewhere right in here. So there's at least a couple of points on the graph. And now the only thing left to do is just put it all together. Actually sketch in your graph here. So if we do that, we end up with a graph that looks something like this. And if that's where one of the curves is, then the other curve has to be in the opposite corner, which means we're up here somewhere. So there's what that should look like. Okay? So to give you a heads up of I've been telling you about the test and things and so on and so forth. Well, finally on Friday we sat down and kind of put together the final test. So to give you an idea, there are 2 of these types of problems on the test. There's 2 graphing ones. Okay? Then in terms of the simplifying, where you're adding, subtracting, multiplying, dividing, the stuff we were working on last week, there's I think 5 or 6 of those total. Okay, with all of those problems. And then there's 4 or 5 of the ones that you're going to see today where you're solving. And that pretty much right there is your test. Okay, those types of things where, like I said, it's basically a page of graphing, a page of simplifying, and a page of solving. Okay, so it should not be any huge surprise to you when you get to the test. The types of problems are going to be similar to what you've been working on. Okay, anybody have any questions on the warm up before we move into the lesson? Anything not make sense? No? Okay. Then let's keep going. I think I've got one more warm-up for tomorrow. By the way, the rest of the week here, we're down to 2 weeks here. The rest of this week, so I'm going to teach you the final lesson today here of Chapter 8. Tomorrow then will be kind of a work day, as usual, on this stuff, making sure that you're understanding the solving equations. We'll go over some questions. Then from there, we're going to start the Chapter 8 review. And start working on putting it all together at that point. Okay, and we'll spend some time doing that, and then your test will be next week. Okay? All right, so let's go to the notes then. Let's go to the notes, which deals with solving rational equations. Here's kind of I put together a process, and it kind of looks like a lengthy process, but it's really not that big of a deal because you've done a lot of this already. This is very, very much connected to what we just came off of, where we were adding and subtracting and finding common denominators and all that kind of stuff. Okay? So if you take a look, when solving rational equations, first off, you need to find a common denominator, just like we've been working on the last few days. Okay? So first part here, part A, factor the denominator and at least identify what is the common denominator, the lowest common denominator. Once you have it factored, like we were just doing on the graphing, you then want to identify what can x not equal, the points of discontinuity, any holes in the graph, any of that kind of stuff. What values of x can we not have anything equal? And what I mean by that in this case, again, is any place where the denominator would equal 0 is a problem. Okay, we've got an issue. At that point, then, we're going to multiply each term of the equation by the factors that are missing, just like you were doing last week with the adding and subtracting, the common denominators. We're going to get a common denominator. Once you have one, then you can go through and you can focus on the numerator. And I'll show you what I mean by that in just a second. Okay? You can drop the denominator, solve the resulting equation, and then because there are values of x, because we have a restricted domain, okay, just like when we talked about the logarithms, things along those lines, things that x cannot equal, at the very end then in part F, you have to go back and just double check to make sure that you didn't end up with any of those things that x couldn't equal. Okay? Here's what I mean by the way when I say you can focus on the numerator here in part D. I'm going to go back to the previous chapters for a second. Okay? And I'm just going to make up a couple of problems just to give you an idea of what I'm talking about. So if I said exponential equation, let's say I said 2 to the 3x equals 8. Okay? If you remember back to when we were doing that before, what we said in this scenario is if you can get the same bases, which 2 and 8 are both powers of 2, so we could rewrite this as 2 to the 3x equals 2 to the third. What did we say at this point that we could do? Now, what can I do? Now that you have the same bases, we'll do refresh my memory here. Help me out.
Just set them equal.
Yeah. Now I don't really care the fact that these are base 2. The bases are already equal, so we at this point before, we just said, all right, now let's just focus on 3x equaling 3 and solve from there. Okay, so if you remember back to that. When we went to, so that was when we were dealing with exponential equations in the last chapter. Then when we went to logarithmic equations, we said that, for example, if the log of 4x plus 5 is equal to the log of let's say 17. I'm just going to make something up. In this, when we got to logarithmic equations, we said if two logs are equal, then we can focus on the argument. We can basically just drop the log part off and focus on 4x plus 5 equaling 17. Okay? You guys remember doing that, hopefully? That's the exact same concept of what I mean right here. Once we have a common denominator, well, now the denominators are already equal, so we don't have to worry about that. Then you can just drop all the denominators and just focus on the numerator. It's the exact same idea as what we were doing previously. Okay? So, let's take a look real quickly before we move into actually solving in some of the examples. What I want you to take a look at is what we also mean what we're looking for when we're checking for extraneous solutions. So let's go to the next problem here, and then we'll go to the slide as well. We'll kind of put those example and the extraneous solution part together. So first part, this one's more basic than what you're going to see normally, but I want to get you the concept first. First question, is there anything in this problem that x is not allowed to equal? Meaning, what I'm really asking, is there anywhere where x would equal 0 in the denominator? There's not, right? Because you've got numbers in the denominator. There's no place where x could equal 0, which means there are no restrictions here, which means we will not have any extraneous solutions. Okay? So, let's take a look. What's my common denominator? Let's kind of just work our way through. Common denominator of what? What is the last?
20.
20, yep. 2, 5, and 4 all are factors of 20, which means, let's get our common denominators then. So first fraction, we need to multiply top and bottom by 10. So we get 10x over 20 plus second fraction, we need to multiply top and bottom by 4. So we end up with 12 over 20 equal to third fraction, we have to multiply by 5. We end up with 15x over 20. And last fraction, we have to multiply by 4. We end up with minus 8 over 20. And I'm going to change that because that's a minus sign right away, so I don't forget the minus sign. I'm going to change that into a plus and then a negative 8 so that I remember that the 8 is negative. So now, here's what I meant before when I said, now that we have a common denominator, all of this stuff, all these 20s are already equal. So I don't really care about the denominators anymore. I can just drop those out of there, and now my focus shifts to just the numerator. Meaning, what I'm looking at now is 10x plus 12, therefore has to equal 15x minus 8. I don't need the 20s anymore. They're already equal. Does that make sense to you? That we can just drop the denominator? Like I said, it's just like the idea of exponential functions. Or logarithmic, where we dropped either the bases or the logs and so on. And now, the rest of it is just solve the equation. So I'm going to subtract the 10x to the right. And if the x's are going to the right, that means I'm going to take the constants and move them to the left. We end up with 20 equal to 5x, which means x equals 4. And there's your answer to your first rational equation. Now, like I said, this is more basic than what you're going to see because normally you're not going to have just numbers in the denominator. It's going to be similar to what you were doing last week, where you got to factor, find a common denominator, all that kind of stuff. But this is the basic process right here. Okay? Let's take a look real quickly. Take a look at the next slide. I'm not actually going to solve anything. The question is whether something is an extraneous solution or not. Okay? So let's say I went through and I solved these two problems. And let's focus first off here on the first one. 10x equals 5. 10x equal 5. Let's say that I found out that x does equal 5. Is it allowed to equal 5? Why not, Monica? Yep. Because if you take 5 and plug it in right here, you'll end up with 5 over 0. Can't divide by 0. So in this case, this would not work. This would be an extraneous solution. Okay? That's what you're looking for at the very, very end. You're trying to check for extraneous solutions. Okay? How about number 2? Will that one work out okay or not? If x equals 5, is it extraneous? This one will work. You plug it in here, you end up with a number other than 0. Same thing here, same thing there. So that one should work out. Okay? So that, just a couple of, like I said, just a couple of quick problems so you know what you're looking for. All right, let's get into some actual examples then. And we'll do some fairly basic ones again to begin with, but then we'll just keep building as we work through the lessons. So first thing, here's a rational equation. Okay, you've got a fractional function here. Think of this 7 as 7 over 1, if you will. Which means, what's my common denominator? X plus 2, right? Because if the other one's 1, that means the x plus 2 is the common denominator. And therefore, let's get a common denominator. We've already got the x plus 2 on the left-hand side, which means on the right-hand side, I need to multiply by x plus 2. So we end up with 3x minus 1 over x plus 2 equal to, I'm going to take this 7 right away and just distribute. You don't necessarily have to right now, but I'm going to, just to clean it up right away. So 7x plus 14 over x plus 2. And real quickly, right now, before I move on, what value of x can we not have in the end? X cannot equal what?
-2.
-2, right. So that's, and the reason I'm putting that down is so that once I finish this off and get an answer, I can very quickly just double check. Oh, but that's the one that x can't equal, therefore it's extraneous. Or that's not the one x couldn't equal, so that is a solution. All right, so now we've got the common denominator, which means now we can drop that and just focus on the numerator. So 3x minus 1 equal to 7x plus 14. And just like the last example, now we just solve for x. Now we're back to a linear equation here. Subtract the 3x over here to the right, which means I'm going to subtract the 14 to the left. We get -15 equal to 4x. Divide by 4. It's not the nicest answer in the world, but there it is right there. -15 fourths, which is not -2, which means it is your solution. Okay? It is not extraneous. How we doing? So far, so good? Okay, let's keep going. Let's go to example number 3 here. This one's a little bit harder because we don't just have one common denominator. There's 2 factors here. Because this is already factored and there's no factoring to do, again, I'm going to have you take a look right away. What can x not equal?
-3.
X cannot equal -3, right? Okay, so that's what we have to check at the end to make sure that it doesn't. Otherwise, what's my common denominator? X plus 3 and 4. Okay, think of that as one factor, and then the 4 is the other factor. Okay, so in the first fraction, we're missing the 4, which means that's what we need to multiply by. In the second fraction, we're missing the x plus 3. That's what we need to multiply by. So we end up with 28 over 4 times the quantity x plus 3 equal to, again, I'm going to distribute the x. So we've got x squared plus 3x over 4 times the quantity x plus 3. And now we're right back to that same spot again. We've got a common denominator. Therefore, you can drop that and just focus on the numerator. 28 equals x squared plus 3x. And I need to solve that equation. How do you solve that equation? Anytime you've got a quadratic, what do you always do? get it equal to 0, and usually factor. Okay? Sometimes it might be quadratic formula, but usually it's going to be factoring. Okay? So if we get this equal to 0, we've got x squared plus 3x. I'm going to subtract the 28 over, and now we solve from there. We end up with x, what is it, plus 7, and x minus 4, which means x equals negative 7, and x equals 4. And if you double check, notice again, as we take a look, neither one of those answers was the value of x that we could not have, which means we're good. We've got 2 answers in this case. All right, let's keep going. Now it gets a little bit more complicated. This is about as complicated as it'll get, okay? Somewhere in this vicinity at least. Where now, if you take a look, now it's a little bit more difficult to take a look at your common denominator. First thing, let's go through and let's actually factor the x squared minus 4. So let's factor that into x plus 2 and x minus 2. We don't have to worry about that. Which means now, what's my common denominator? Now it should be a whole lot easier to look at. Oh, what is it? X plus 2 and x minus 2. You got to have the same factors. And so in this case, we've got both factors in this one, so I don't actually have to do anything to this. The first equation has the x minus 2, but we need the x plus 2. The second one has the x plus 2, but we need the x minus 2. So let's multiply by what's not there. X plus 2. And then we've got to x minus 2 in the next one. And again, I'm going to take the 3x and distribute. So we end up with 3x squared plus 6x over our common denominator plus, since we're just multiplying by 1, that just gives us x minus 2 over our common denominator. And then the last part, like we said, we don't actually have to do anything with the last one because we already have the common denominator. And again, right now, before I move anywhere else, what are the values of x that we cannot have in our final answer? X cannot equal what? 2 and negative 2. Okay? If it equals either of those, we have extraneous solutions. And so, we've got the common denominator. Drop the denominators and focus on the numerator. 3x squared plus 6x plus x minus 2 equal to 4. There's the rest of the focus, and once again, we're right back to a quadratic equation again, which means clean it up, get it equal to 0, and then either factor or quadratic formula, one of the two. So we have 3x squared. This gives us 7x. And when I subtract the 4 over, it gives me a minus 6 equal to 0. And now we see if we can factor here. Factors of our first term, we've got 3x times x. And now we got to see if we can get factors of our second part here. So it could be 6 and 1, could be 2 and 3. Okay. Again, I'm just going to kind of check some things here. So let's say we put in here 2 and 3. Remember what we're checking is the inside and the outside to see if we can get that middle term of 7x. So I've got a 2x, and outside gives me a 9x. Sure enough, from 2 and 9, I can get a 7. And I need a positive 7x, which means that's got to be positive, and that's got to be negative. Okay. We end up with inside is a negative 2x, outside is a positive 9x when you multiply. And now we're right back to zero product property again. This one, x is going to equal 2/3. When you solve that. And this one we end up with x equal to negative 3. Once again, it turns out that neither one of these happens to be one of the values that x cannot equal, so we don't have any extraneous solutions. All right, I want you to try one now on your own. Anybody have any questions before we're moving on? It seems like the feel I'm getting is it seems like it's making sense. Go ahead and try that one. Example number 5. Try that one on your own. Here's what you should have come up with. So the only thing, so x minus 2 is your common denominator. So the only thing that was missing the common denominator was the 7. You got to think of that as 7 over 1. So multiply both top and bottom by x minus 2. That gets you to this fraction right here. And then from there, you're right back to where you normally were. Okay, x cannot equal 2. We drop off the denominators and focus on the numerator. And it turns out that it ends up being x equals 2 is the only answer you get, which is the only answer you're not allowed to have equal, which means, by the way, what's the actual answer to this problem? No solution. If this is the only possible answer and you can't use that as an answer, that means this answer is no solution. There is no value of x that will make this a true statement. So this one is no solution. Let's have you try one more on your own. Try example number 6, last one. This one's a little bit more complicated than the last example was. Alright, we switch here. Get y equals -4. Hopefully. That's what I got. At least I was rushing, but that's what I got. As you look, take a look through. So common denominator here is y plus 1 times y minus 2. So the first fraction has one of the factors, but missing the other one. The second fraction has one of the factors, missing the other one. The third part, the 2, doesn't have either of the factors because it's 2 over 1, and therefore you got to multiply by both of those factors on the right-hand side. That's what makes this one obviously more complicated than the previous ones. So when you multiply y times y minus 2, there's your y squared minus 2y. When you multiply y times y plus 1, you get y squared plus y. And then here, if you multiply this out, remember you got to FOIL this whole thing out. Y plus 1 times y minus 2, you end up with y squared minus y minus 2, and then you still have the 2 that's in front as well. Okay, that then needs to be distributed. So right here was where I identified that y cannot equal 2, nor can y equal -1. Those are our problem areas. And then we just focus on the numerator at that point. Dropped off the denominator. So here's our y squared minus 2y plus y squared plus y. And then this, the only thing that I did was just distributed the 2. 2y squared minus 2y minus 4. And then it's just start moving stuff around. Well, it turns out you've got 2y squared over here. Well, when you subtract it, all the y squareds will actually go away. Those cancel each other out, all three of those. -2y plus y, I put those together. But then we have to add the 2y over, which gives me y, and the only thing left then is the -4. That's where that's coming from. It is not one of the problems, one of the two values that y is not allowed to equal, and therefore y equals -4 is your solution. Like I said, these are about as difficult as it'll get, where you've got the multiple factors, you got to FOIL things out. There's a little bit more algebra involved too. How we doing? Feeling okay about this? Feeling like it's doable? Okay. Like I said, so I'll give you the assignment today. You've got a little bit of time here yet. You've got about 5-10 minutes here where you can still go through and get at least practice a couple more problems. Then tomorrow will just be a practice day again, making sure that you're focused on this, making sure that you're understanding everything. And then on Wednesday, we'll start to put it all together. Okay? How do you know when you need a common denominator versus not, and all that kind of stuff. So let me get to the worksheet, and like I said, you can at least get started on that, do a couple of problems. And as always, answer key to the worksheet is out on Canvas. Please make sure you're checking your answers. Okay? You want to make sure you're doing this correctly.